Good morning, children. This is 10th physics. We are going to do the chapter that is light. Today we are going to start with the topic lens. Now, what is lens? Lens, as you can see in the picture, is a piece of transparent material, right? Now, this lens, it is bounded by two surfaces, of which either beta one surface is spherical or both the surface may be spherical. So children, this is your definition of lens, that it is a transparent material which is bounded by two surfaces, either one surface or both the surfaces are spherical. Now children, there are two types of lens. One is your convex lens and other is your concave lens. Let's understand them in detail. First is your convex lens. Convex lens, if you see its structure, in the middle it is thick as compared to the edges. So convex lens is a lens which is thick in the middle and it is thin at the edges. Moreover, convex lens converges light at a point. It is going to, suppose the light is coming like this from the left. So children, it is going to converge the light at a point, right? It's going to bend the light at a point. So as it converges the light at a point, it is also known as converging lens. Let's see the second lens, that is concave lens. Now let's see its structure. If you see the structure of concave lens, in the middle it is thin, but at the edges it is thick. So this is your concave lens. Concave lens is a lens which is thin in the middle and it is thick at the edges. And concave lens is also known as diverging lens because it diverges the incident rays, because it spreads out the incident rays. For example, the incident rays are coming like this from the left. So it is going to diverge them out. It is going to spread them out, right? So concave lens is also known as diverging lens. Now, there are various types of convex lens depending upon their surfaces. Now, if you see the first type over here, children, this here both the surfaces, they are spherical, right? And both the surfaces are convex, means in the middle they are thick and at the edges they are thin. So this is, as both the surfaces are convex, they are thicker in the middle and thinner at the edges. So this is your double convex lens, which is simply said as convex lens, right? This is the lens which we are going to study in this chapter. Now, let's see the second type of convex lens. Now, here if you see, one of the surface is plane and the other surface is bulging outwards. That is, it is thick in the middle and it is thin at the edges. So, this is your, this side is plane, this is convex. So, this is your plano-convex lens. Right, children? Now, if we move towards the third type of convex lens, then you will see that here this surface, yes, it is concave. Sorry, this is convex, right? But this surface, this is concave, right? Now, if you see, the thickness of the lens has decreased as compared to this, right? Here this lens is formed with a combination of a convex surface and a concave surface. So it is known as a concavo-convex lens. Now children, let's see the types of concave lens. Here also children, depending upon the surface, there are three types of concave lens. The first one, as you can see, both the surfaces are concave, right? They are thinner in the middle and they are thicker at the edges. So this is your double concave lens. Next is, if you see one surface, this surface is for convex surface and this is your concave surface. So this is your convexo-concave lens. Convexo-concave lens, right? Now here if you see children, one surface is plane and the other surface you can see it is concave, right? As here this was concave and this was convex, right children? So similarly here this surface is plane and this is concave. So this is a combination of a plane surface and a concave surface. So it is your plano concave lens, right? Now this double concave lens is simply called as concave lens and this we are going to study in this chapter. Now let's start with some terms, some terminologies for the convex lens, right children? The first thing, if you see these two surfaces, if you see children, these two surfaces of a convex lens, they might have been cut from a sphere. So children, this surface, let me change the color. This surface might be cut from the sphere and similarly the blue surface might be cut from another sphere, right? So the reflecting surface, these are what? These are the reflecting surface of the lens. यहाँ से light reflect होगी, right? यहाँ से आपकी light जो है उसका refraction होगा, right children? So these are the refracting surfaces of the lens. So they are the part of a sphere. They are cut from a sphere, right? And this sphere has a center, right? So your convex lens, so children, your convex lens, the reflecting surface of the convex lens, it forms a part of a sphere and this sphere has a center. So this is called the center of curvature, right children? The lens, it has two reflecting surfaces, right? Now this surfaces, they forms a part of a sphere. ये किसी sphere का part होंगे जहाँ से इसे cut किया था, right? So the centers of these spheres are your center of curvature. Next, this was for your convex lens, right? Now, let's see for the concave lens. Let me zoom it a little and this is your children concave lens. Similarly, here we are having two reflecting spheres. These two reflecting spheres, they also forms the part of the sphere. This surface forms a part of this sphere and this surface forms a part of this sphere. And these spheres, they have centers. So that these are the center of curvature for a concave lens, right children? Now this is our next term, that is optical center, right? Now as the word center, it is the center of the lens. So it is the center of the lens. What is optical center? Optical center is the center of the lens from which the light ray is going to pass undeviated, means no refraction of light is going to take place. The light is going to straight away pass through this point and this point is known as your optical center. Yes children, so optical center is the center of lens through which the ray of light passes undeviated and it is represented by the alphabet O. So here you can see the optical center as well as over here, right? Next, your next term is the principal axis. So we know x-axis, y-axis and z-axis. So they are what? They are lines, right? So similarly, here also principal axis, it is an imaginary line. It is not a real line, right? But it's an imaginary line which passes through the center of curvatures of the lens. Now, as we know, there are two center of curvatures in a lens. This is C1. This is C2, right? This is for a concave lens. This is C1, this is C2, and this is for a convex lens, right, children? Now, the imaginary line that is passing through the center of curvatures of a lens is your principal axis. And children, if you see, the principal axis is perpendicular to the surface of the lens. Yes, children? So this is the third term, that is principal axis. Now, very important term which comes in 2 marks question, that is about the principal focus. Principal focus. Principal focus. Now, we are going to do the principal focus for a convex lens. Now, as we know, convex lens is a converging lens. Yes, children? So, here, these are the incident rays. Right? Now, all these incident rays, after refraction through the lens, they are, just a minute, they are going to meet at a point, right? Convex lens is a converging lens. So, all the incident rays which are parallel to principal axis, if you see over here, beta, the blue color incident rays, they are parallel to the yellow color principal axis. Yes, they are parallel to yellow color principal axis. The blue color are the incident light rays which are coming from the left, right? Now these rays, after refraction through the lens, when they will enter the lens, refraction will occur, and after refraction, they will meet at a point on the principal axis. So this point is called the principal focus. This point is called the principal focus. So here you can see these are the incident rays parallel to principal axis. After refraction, they meet at a point, and this point is on principal axis. So this point is your principal focus, which is denoted by the alphabet capital F. So here is your definition of principal focus. That is, principal focus is a point, right? Where is the point? It is on the principal axis. Yes. Where all the incident light rays, but which incident light rays? Those are parallel to principal axis, right? They actually intersect, they actually meet after refraction from the convex lens. We know, children, that the incident rays, when they enter the lens, refraction of light is going to take place, right? So after refraction, they all are actually meeting at a point, and that point is on principal axis. So that point is your principal focus, right, children? So principal focus of a lens is a point on the principal axis where all incident light rays, they actually meet. But which incident light rays? Those rays which are parallel to principal axis, right? They actually meet after refraction from the convex lens. So in convex lens, the refracted rays, they are actually meeting, right, at principal focus. This is very important. This is a 2-mark question in your board exams. Now let's move towards the principal focus of a concave lens. Now children, We know concave lens is a diverging lens, means it's going to spread out the light. So as you can see here, these are your incident rays, and beta these rays you are going to draw till the center of the lens. At the center of the lens, what you can do is you have to draw a line, perpendicular line, right? Now, here if you see the incident rays, they are parallel to the blue color principal axis. Now, when they enter the lens, refraction of light will occur and the rays will be refracted. So, the rays would be refracted like this, and like this. Okay, children? Now, will they ever meet? No, they cannot meet. So what we will do? We are going to imagine. We are going to extend them backwards. So if we extend them backwards, then children, yes, this is the point where they are meeting on the principal axis. But children, they are actually not meeting, right? They appears to meet. So the principal focus for a concave lens is also a point on principal axis where all the incident rays which are parallel to principal axis, they appear to meet, right? They appear to meet after refraction. So here is your definition. Just a sec. Here it is. Just a minute. Here it is. Okay. So principal focus of a concave lens is a point on principal axis where all the incident rays, those are parallel to principal axis. See, they are not actually meeting. So here you can observe the word appears to meet after refraction from the concave lens. So this point is your principal focus for a concave lens. Next term is focal length. Next term is focal length. So focal length and principal focus, yes. So we are going to relate something, right? So focal length has the word length, so it is a length, right? It's a distance between what? It's a distance between the principal focus point and the optical center. So here we know this is your principal focus F and the center of the lens is your optical center O. So distance between them, that is principal focus and the optical center of a lens, is the focal length F, and it is denoted by small f. Similarly, if you observe for concave lens, this is your principal focus, and this is, and the center of the lens is over here. So distance between them, that is distance between the principal focus and the optical center, is called the focal length of the lens. Now the last term is aperture, right? So aperture is what? It is the diameter of the spherical lens, right? You are having the outline of the lens, so its diameter. So this thing, that is this thing, right? This is your aperture. So aperture is the effective diameter of the circular outline of a spherical lens, is the aperture. Right, children? So with this, we are done with the terminologies which we are going to use for the lens. Okay? So thank you, children. We'll end our class here. Bye-bye, children. Take care.